And those are my true feelings about Riley and Kalisha and Delilah. All right, so here we are. We have this related rate problem. Ladies, first of all, good luck tonight if you're watching this on Thursday. I hope that's the case. But we are just jumping in. We're going to do one problem right now, and then we'll probably bounce back and forth between working stuff together or not, because there are several problems within the book just right away that after we do this problem, they're going to be like very similar for you to get practice with. So here we are trying to find out when a spherical, weird, I didn't write it. Did you? Did you guys write a spherical? No other word? Yeah, I said balloon, and Rafa wrote balloon. There's a balloon here. I did not have that word. It didn't make sense without that word. That's my bad. A spherical balloon is inflated at the rate of 10 cubic meters per minute. We want to find the rate at which the surface area is increasing when the radius is 3 meters. Now, as we look at this, gross sounding, really easy problem to do, I think, as long as we can find a formula for it. But I don't even know where to start. Are we volunteering or am I picking random? Oh, Rafa's got it. Yeah, I'm going to start with a picture. Now, my picture might not be super meaningful, and that's okay. If I have a sphere, right now it just looks like a circle. How do I make it look like a sphere? So a radius would still just make it look like a circle. Draw the equator. Whoop. There it is. And if you really want, you can draw the equator in the back so it's even more spherical looking. And now we have a sphere. Okay, so we have this lovely sphere. And on this sphere, all I know is that we're going to be dealing with a radius at some point. Now, it doesn't really matter how I draw it, and I do agree, and I wasn't like trying to be snarky with it. I don't think it came off that way. But that is my radius r. Okay. Now, it's good idea. Do you guys want us to set them up like we did with physics with here's what we're given, here's what we're finding, and all that? Like, it's a good approach. I'm going to keep doing it. You guys can do it if you want or don't. It's up to you. But let's just go ahead and start. Whether I write knowns or givens doesn't matter. What is something that I know about this? Now, we're looking for those key words to make me think something about a derivative. So I never wrote, I like your idea, but I don't see the word expanded. So I see the word rate for sure. So this tells me what I'm trying to find. But I think I'm given something that's also a rate. They don't say it like that. I'm given dV dt, the change in volume. How did you know that? So meters cubed per minute tells me I'm talking about a volume. This situation, inflated, is what I'm looking for. There's something changing. Inflating, it just means we're blowing up the balloon. That's it. Now, I will look into it. Depending, most of the problems don't have any wonky words like this. Like, I don't think that this word's super wonky. But if you would like anybody in here, whatever the language would be, if you want me to reach out to the college board about the option of possibly getting one in Tagalog or any other language, let me know. I assume that they can accommodate that because AP goes worldwide, not just in the US. So we can probably make that happen. But we do know this, and Abigail, you're right. I like that this inflated thing, and more so at the rate, tells me that there's my rate of change. It's a volume, dV dt. And what is dV dt? 10 cubic meters or meters cubed per minute. There's dV dt. What am I trying to find? How do I write, what variable should we use for surface area, do you think? It's ds dt, and it's a capital S, just so you guys know by default for area stuff, capital A for area. In geometry, you probably used SA for surface area. We're just going to use capital S so we don't get gross with it. We're trying to find ds dt when? When the radius is 3 meters. When r equals 3 meters. Now, this next part, it doesn't really have a good way to work out, but we need a way to relate this information to each other, like hence, again, the name related rates. So this is, I've never seen this done like in this setup, but I think it's a good practice just to make sure we can get good at these, to write down what variables do we have. So I'm just trying to think. I know that this is a derivative, but this is the change of what value? What's the capital V represent? So we have a volume, we have a surface area, and I would probably just make the note surface area. Okay, and anything else that we have? A radius R. Okay. Huh. All right, well, I'm stuck. The surface area might be kind of tricky. We'll have to get that part out. Is there an equation that relates these three things? Now, I want you guys to do me a favor. Check in the back of your book or in the front, and we're going to dig through the index pages for a second. We're going to see if we can't find some of these lovely three-dimensional geometric figures. And I'm just looking back through stuff. Oh. Okay, I'm on the third page from the back, and I see that there's a bunch of reference stuff in here. We open it up, we get the integrals. We go a page back, we get the derivatives. We go a page back, we get the trig and parent functions. And one page past that, we get conics on one side, your lovely conic sections. And on the other side, we get formulas and equations. Now, we're going to encounter something awesome or terrible. We'll see. I don't know that there's an immediate way to represent all these things together. But using those reference sheets, did you guys find them? Okay, so we're going to go ahead and just write out our equations. And I'm going to write this a little bit differently than we did in physics. Related equations is how I'm going to state this. Just to really emphasize that, yep, we're relating these things. So I need either, we're talking about a sphere, which is nice. There's no equation that links together all three of these, but there's a few equations, at least there's two equations rather, that we can use. Sean, there's one equation that you started to read that I think you kind of peeled off on. It might not have been you. The surface area is 4 pi r squared. Now, can you tell me the issue with only this equation? There's no volume in it, right? Like, I don't know what dr dt is. If I differentiated it, I would have trouble. All right, so bummer. Okay, we just pack it up, we're done, right? No. Thank you for not all saying yes, like normally happens. You might have all thought it, but, well, what else do I need then? If only there was something else I could do. Volume. What's the volume of a sphere? Okay, I'm going to write that a little differently. I'm going to write it as 4 pi thirds r cubed. And why? What's the whole point of doing this? So pi is a constant, so I guess let me be more specific with my question. Why did we need another equation? I'm going to give you guys like 30 seconds because that can be, or a minute if we need it. That's kind of a bigger question. I know that I've said the answer, but I want to make sure that more than, not to be rude, but I don't want you guys to just parrot answers to me. I want to make sure that you truly understand why we're doing this. So 60 seconds, chat with your neighbors. We're going to see if anybody comes up with a good explanation. I'll come around and chat with small groups as we go. It'll probably be more than a minute if I'm going around to talk. But talk it out. Why did we take the time to write a second equation? That's the question at hand, and we'll be right back. Now, there's two different ways to go through this problem, and I don't really care which way we go, but just to really make sure. If we pretend like we didn't recognize there was an issue and that we needed a second equation, because it's possible that you miss it, right? I'm going to try to demonstrate really quickly, and this is entirely up to you if you want to include this or not. But all that I'm going to do in yellow here, I'll erase in a minute. But I just want to see what would have happened if we tried. If I tried right here, as soon as I saw this, to take the derivative, I can do this. I think I get ds dt equals, what's the constant multiple on this one? So a 4 pi hangs out, and I'm going to, before I write it, what's the derivative of r squared with respect to t? 2r dr dt, right? So I'm just going to keep in mind that there was a 4 pi, and I'm just going to move that 2 up front. It's 8 pi dr dt. In this situation, it feels okay, but what do we plug in here? Ooh, I can't draw. I was going to try to draw an upside down question mark, but I can't do it. Nope. That is much harder than I've never drawn that before. Nope, not going to do it again. We don't have it, right? That's an issue. Now, maybe by happenstance, we've done it here, and I'll just do this one in a slightly different color just to see what would have happened. If we had done this one instead, I can certainly get dv dt out of the deal, no problem. And this would be 4 pi thirds times 3r squared dr dt. So this winds up being 4 pi, and then the 3 is divided out, so I'm cool with that, r squared dr dt. We run into the same issue, don't we? Like, we still don't know dr dt. So, Sean, I like your idea. I don't know that I'm going to do it straight up that way. There's two options. Sean's idea, if you didn't catch it, I think, and correct me if I'm wrong, okay, was that we can do this, we can plug in dv dt, and we can solve for dr dt when r is 3. We could get a value for dr dt. Now, if you don't want to have to do dr dt there, that's okay. Is it possible that we could write s? Can we solve r in terms of s? Like, can I solve this equation for r, or this equation for r? Now, I don't care which way we go. I actually do care which way we go. Which one's better? Should we solve this and plug in what we know and get dr dt? Or should we try to tie these equations together by solving for r? I'm okay with either way. We're going to try both of them, is my guess. Do you guys understand the question I'm asking? Do we? Cool. Talk with, same thing. We're going to go back and forth over and over. Do you want to solve for r and substitute it into the other equation in one of these? Or do you want to try to solve for dr dt? That's our question at hand. I'm going to give you guys a second. We'll go with whichever one we agree on. All right, Fern, in no particular reason, are we going to try to solve one of these for r and then substitute it in, or are we just going to solve for dr dt? Okay, follow up. Which one do I want to solve dr dt for? The bottom one? Okay, I'm fine with that. So I'm going to annotate this much more than we have, and we'll look at this problem while you guys are working on stuff. I'll work it the other direction, just so we can look and see, like, hey, is it really any different? I'm not going to make you guys do it 2 different ways, but I want you to see that there are multiple ways. Okay, so if we have elected that we saw that there were problems there, and I just erased it, I'm going to make just a note. We need, or we will, rather, solve for r, or for rather dr dt, and I'm fine with that. Okay, and I'm going to use this orange equation. So to get a dr dt, I've already done this, but we get dv dt. And this time when I do it, I'm not going to do all the shortcut stuff in my head. I'm going to make sure that we all see where the derivative comes from in case you struggled with it. Okay, 4 pi thirds is my constant multiple here. And then what's the derivative again of r cubed? 3r squared times dr dt. Thank you, Ms. Cabal. Okay, those 3's divide out, and we're one step closer. We see that dv dt is equal to 4 pi r squared times dr dt. And one more step away. What's dr dt then? Good. And I'm going to make it uglier, but I like that idea. If you want to use v prime instead of dv dt, I'm cool with it. It's going to make it look nicer. I'm just going to do it this way. dv dt divided by 4 pi r squared. And it's ugly, but we have it. Now, we run into that weird little situation. V prime is nice notationally. Remember, there's some wonky stuff going on that we're not going to go into the real details of, but dv dt is not just a fraction. We can't just multiply here. Like, we write it as a fraction, we treat it like a fraction a lot of the time, but we're not just going to multiply by 1 over this. Like, we're going to keep the division. And it feels weird, but it's a weird fraction, so I'm okay with that. All right, so we've done that. Now what? We're trying to find ds dt, right? So I do want to highlight, we could have solved either of these for dr dt, but this one's like the perfect one, because now when we differentiate this, we already have ds dt by itself. Like, that's super convenient. So we have this, We're going to use our drdt. We'll plug this in for it here in just a moment. I'm going to box this with some dashed lines just so I don't think it's my answer, but I don't want to lose it. So now we have it. Now let's actually find what we're looking for. So we're going to take the derivative of what other function? S. So we're going to take the derivative. Now differentiate. And I should have just said ddt, but that's okay. Differentiate S. So let's do that. I'll do the left side. It's ds dt equals, what's that constant multiple on S again? 4 pi. And then Angel, I don't call on you very frequently. You're the furthest person from me in the classroom. What's the derivative of r squared? Love it. 2r times dr dt. Now, when we started the problem, I made us look and see like, hey, look, there's issues with this. Do those issues exist anymore? Like, I'm not so concerned about dr dt because Sean's suggestion from the get-go was awesome. Let's use this expression for dr dt. Now I get my dv dt in the problem. I don't have to worry about drs, but I do have a place to plug in r still. So I will keep this color-coded. This is 4 pi times 2r times, and I'll switch to this lovely orange, dv dt. And I'm going to use brackets only because I think they look nicer, over 4 pi r squared. Okay. At this point, do I have my full derivative? Yeah, pretty sure. And I'm just going to check before I like commit the energy to do this. Do we know what r is supposed to be? Do we know dv dt? Those are the only things in this equation. Can we plug and chug? Do it to it. Let's see if we get the same answer. I want you guys to plug and chug. Work on your own. I'm going to do it up here also. I'm just plugging in values. So I'm going to annotate a little bit. Now, evaluate. Meters cubed per minute, right? Oh, man. There's some awesome stuff that's about to happen. Wake up. Now, if you guys noticed it, the 4 pi's divide out. Cool. And then let's just see. We wind up with ds dt, and hopefully we get the same answers. And that is right. That's the last little challenge. That's 2 times, what's r? 3. And then since my 4 pi is divided out, I'm just going to multiply this, and I'm going to switch to parentheses now. What's dv dt? 10 over, what's r squared? 9. I'm just going to write 3 squared so I can just do this. But by 9 is the same thing. Cool. That's everything, right? What did we just get for our rate of change? 20/3. And let's play the unit game really quick. And I'm cool with doing it here. This was a radius, right? So this was in, and can I do it over here just so I don't have to shove it in here? This was a radius, and it was in, what was the unit on the radius? Meters. This was a volume, or a dv dt, and it was a change in the volume, which its unit was what? Meters cubed per minute. And then we divided this by, What was r squared? What would that give me? Would it just be meters? It'd be squared. Okay, so as I'm looking at this, let's see, I get m to the fourth over m squared, which would give me what? M to the, do you guys see where my m to the fourth is? Okay, m to the fourth over m squared is just m squared, right? And then what's still downstairs? Per minute. Is this how area should be expressed? Yeah, it's area is meter squared, the time is per minute. So this is a change. So I'm cool with that. I've convinced myself that at least our units didn't get goofed up, so we must be all right. Okay, the last point on every single one of these problems. Where does it come from? Like, we've done all the calculus, we've done all the algebra. It's probably really annoying that I do this, but we need a context. You guys get like 30 seconds. I'm going to make a couple of people read it. I want you to write me the sentence explaining what we just found. Remember, we don't say it. For our contextual answer, one thing, like I'm going to stress this over and over, because if you just say it, they will not give you credit for it. I probably would, because I'm not a monster like the College Board. I mean, I am a monster, but nowhere near like they are. The surface area of the balloon, don't say it, be super specific, is increasing at that rate per minute squared, sorry, meter squared per minute when the radius is 3 meters. Somebody read me the sentence that you wrote. Hit it. So the only thing, depending on who you get to grade your test, if you don't say surface area, I'm not sure you're going to get it. Like, I know what you're talking about, and you know what you're talking about, but make sure nobody could pick it up and play dumb and not know what you're talking about. Cool, I like it though. Anybody else? Different one? Okay, I'm cool with that. So with this, we are going to use the book today. We'll do the worksheets tomorrow. I already have them all printed out, but I think that the book is nice to have in front of you with examples and things like that for now, especially to check your answers and such. Okay, for a few minutes, and this could go till the end of the hour. We'll just see how long it takes. I want you guys to do what we'll call homework 4.1.1, and this is day 3 of these, right? This is the third day of related rates? Second. Third? It's Thursday. Okay. Homework 4.1.1. I got to find the page that they're on. They begin, I think, on page 284. So, page 284. And I want you guys to work 4 problems for me. It is 11 and 17. And then I want you to do AP 1 and AP 4. Okay. About 20 minutes. 4 problems is probably going to be cutting it close if we're able to finish. Remember, I'm going to let you guys work. You're cool to move desks, work together. I try pretty hard to not just eavesdrop on everything. My teacher ears are always open. But I'm going to trust your guys' judgment. If you have no idea what to do or you catch yourself just copying somebody else's work, what should you do? Yeah, talk with me. I will help clear it up. Like, that's my job. It's what I like to do. Cool. We'll get some chill tunes going unless somebody has a better music suggestion. Everybody love that song Friday by Rebecca Black? Me neither.